this lecture, let's talk about the solution of equation of motion. Solution of equation of motion. So just assume that let the spring is massless. So equation of motion, we know that equation of motion in this case is x double dot plus omega n square x equal to 0. So let's we can expand this expression, and like we can write this expression as d square x by dt square plus omega n square x equal to 0. So just replace d square by dt square by d term. So we can write d square x plus omega n square x is equal to 0. So we can see that d square plus omega n square by taking x common out. So this is basically a differential equation, and we know that let me raise this thing first. So we know that solution of x is equal to function of t, that is solution of x is equal to complementary function, that is cf, plus particular integral, that is pi, where in this case pi is equal to 0. So we have to find out the complementary function. So our main objective is to find out the complementary function cf. So let's solve here. So d square plus omega n square is equal to 0. So we can write this thing as d square is equal to minus omega n square, and after like solving this thing, we are going to get d equal to plus minus I, that's iota omega n. So the solution for the displacement equation, so the solution for this is so solution in this case is x equal to a cos omega n t plus d sine omega n t. So this is a displacement. So this is a displacement equation. So this is a displacement equation. So here where a and b, so a and b are constants, and whose value depends upon boundary conditions. So let a equal to x sine phi and b equal to x cos phi. So after solving, like we can see that x square equal to a square plus b square, and we can see that tan phi is equal to a by b. So just substitute the value of a and b in this equation. So we are going to get, let me write this thing first. So we are going to get x is equal to x dot sine phi dot cos omega n t plus x cos phi dot sine omega n t. So just we have to simplify this term, this whole equation. So we are going to get, after simplification, x equal to capital X sine omega n t plus phi. So this is the equation of our interest. Here x is the amplitude of displacement, omega n is the natural frequency of the displacement. Omega n is the natural frequency of displacement. And this whole thing is the displacement equation. So in order to obtain the velocity equation, just differentiate this equation. So we are going to get like x dot capital X dot omega n cos omega n t plus phi. So this is the velocity equation after differentiating the displacement equation, velocity equation. So few things you should keep in mind that let me raise this thing. So if we are going to calculate time period, so the time period t is equal to time required to complete one cycle, and here t is equal to 2 pi by omega n second. Here amplitude means the amplitude x of displacement, is the maximum displacement of the given system from its mean position, Now what is the frequency? So frequency is the number of cycles per second, and we can find out by frequency equal to 1 by time period, that is 1 by t, is equal to omega n upon, that is the natural frequency, upon 2 pi. So its unit is hertz. So it is hertz or per second, or per second. Now another thing you should keep in mind, that let me erase this thing. Now another thing you should keep in mind, that that the phase lag, the phase lag, the phase lag between velocity and displacement, the phase lag between velocity and displacement is 90°, whereas between acceleration and velocity the phase lag is 90°, and phase lag between acceleration and displacement is 180°. So this is the whole concept for this lecture. So in the next lecture we will be starting like something new topic, that is analysis of damped free vibrations. So for now, thank you.